Hello, okay. The microphone is on. So yeah, I'm happy to be here and I'm happy to be joining you, Kenneth. Let's look at our agenda. It was already mentioned. Introduction, a bit of DynamoDB, Aurora PostgreSQL Limitless database, Aurora DSQL, and then final conclusions. And hopefully we will have time for your questions as well. Which services/features we'll be discussing today? Of course, Amazon Aurora Postgres, the DSQL, Amazon DB, and Amazon DynamoDB global tables. So let's start with DynamoDB. First of all, who knows what are DynamoDB global tables? Okay, a lot of people know them. We can also look at the animation, how it looks like. Basically, what DynamoDB global tables are, they allow your DynamoDB to be replicated in a different region. It can be useful for many things. We'll get into it in just a second. But this is how it looks like, basically. So you have some function that will push something to your DynamoDB, and then we do a bidirectional sync to a different region where you also have a DynamoDB table. So why is this useful? You might ask. Well, first of all, you have faster access to data. So if you have users or you have your engineers in some specific region and not in your region, the data will be already replicated. And also, in case something happens and there is a big outage in your region, the data is always replicated in another region and it's available. So how does the data replication in DynamoDB work? Well, first of all, it is async. I really don't like this word. So the data is replicated asynchronously along the different regions, of course. And everything is managed by DynamoDB, although there's also a GitHub repository available if you want to do replication between, let's say, China and, I don't know, some Europe region. So yeah, mostly it is no manual intervention and it is all done by DynamoDB itself. Except this, we use something called last write wins rule, which means the most recent update will be kept while it will be syncing. And of course, you have to be real careful if you're doing multi-tenant apps due to different simultaneous updates happening at the same time. And there can be data conflicts that we will look at in just a second. And yeah, you can also scan the QR code. You'll see a YouTube video, which is quite nice, and it will also explain it in detail. So what are different use cases? Of course, there's a lot of different use cases for global tables. It can be real-time analytics. It can be fast content distribution. It can be live gaming leaderboards. It can be reliable financial transactions. Very specifically, if you're a bank, this is something that you would use most likely. Also, e-commerce scalability. And I hope I'm not covering the presentation. So yeah, something to keep in mind. And you can also use Route 53 and combine different serverless solutions together to have replications of your entire, let's say, architecture in different regions. So yeah, this is also quite helpful. But let's look at what is under the hood of how the replication happens. And we call it eventual consistency at the moment. And something new was introduced in December that we'll also look at. So yeah, this is from the official documentation. Eventually consistent is the default read consistent model for all read operations. What it means is, let's say I'm a user, I have my DynamoDB, we are both in the same region. I send some API requests, in this case it is update item. So I write something, let's say I wrote in my table some entry. And when I do get item, will X be retrieved? Unfortunately, with eventually consistent read, it won't. It will take some time for the data to be retrieved back to me. For this reason, we have introduced something called strongly consistent reads. So if you have read operations such as get item, query, and scan, when you call the get item as an example, and you set the consistent read equals true, the X will be retrieved straight away. So you don't have to wait a couple seconds, actually milliseconds, and you don't have to like click again to retrieve whatever you have in your DynamoDB. But let's look at multi-region setup, right? So if there's a user from a different region also trying to access the DynamoDB, and he tries to get item while I have already written something in my DynamoDB, the data might be stale, which means it will take some time for it to update. So what now? What if I am, let's again take bank as an example, right? I have some credit card information that I have to retrieve and the data has to be like right there. Can we do something better? So on the reInvent in December, AWS have announced something really cool. It's called strongly consistent replication. So what happens is when the user from a different region will try to, let's say, get item, the item will be retrieved without having to wait any milliseconds. So to understand how this works is we have to look at the consistency and first try to understand what is consistency. In our case, consistency refers to whether a particular read operation receives all write operations that have occurred prior to read. And we can also look at this diagram from actually the DynamoDB book. What happens is we make a request which is authenticated, a partition key will be hashed and is sent to primary node. As you can see, we have 3 different types of partitions. We have one, let's say, master or main node, and we have 2 children. So yeah, the primary node will make the write and save it on one of the child nodes as well. And we have to keep in mind that writes are replicated asynchronously, and due to this, child nodes may be behind the primary node. But in the newer solution, where we have strongly replicated DynamoDB and we don't have to wait for anything, we enable replication synchronously, so it's not async anymore, along all of our configured regions. So when a write is performed in one of the regions, the change will not be acknowledged until it has successfully been applied to all participating regions. And yeah, this is of course different from what I just explained. So instead of writing to a single master node or main node, as we mentioned just now, each region in a global table will act like a fully active region, so write can occur in multiple regions at the same time. So, okay, this is cool, but why is it so important, you might ask? What is RPO? Who knows what is RPO? Okay. RPO is the maximum amount of data loss that is tolerable for a organization, and it helps to, of course, determine the frequency of backups that are needed for the data to be recovered at the acceptable time frame. Why is this important? Because let's say we have some type of, let's say, data. In our case, we have Milan and Stockholm. We have a user, an application. Something happens to the application. In strong consistency, you will straight away have replicated region, in our case Stockholm, and you won't have to wait any time. Like it will be available and you can change the traffic from one region to another for your application without having to wait for anything. So there will be no downtime, and we call this RPO is 0 in our case. Some things to keep in mind. First, of course, this is just in review, so it is not ready for production at all. Also, currently, if you want to use this feature, it is available in only 3 regions, and also requires 3 region deployments. It is available in US East, East 2 and US West 2. Something they also mentioned is strong regional replication uses more resources. That's what they mentioned, and I am assuming since it uses more resources, probably it will reflect on the pricing. I'm not sure, it's not written yet. And we can move on to Kenneth's part.
So we're changing a bit the subject now. It's going to be on Aurora. So this is when I was querying about both Limitless and DSQL, and I started asking the normal questions. Yeah, what about read replicas? What about blue-green deployments? This guy told me, forget everything. It's a new chapter. Everything is new. And basically, you need to start from ground zero. So, yes, I thought, yeah, he's joking. No, it's true. So, let's start with PostgreSQL Limitless. So, it is serverless. It can manage a petabyte of data, and we say how. It can process millions of write transactions per second. It's a single database. Usually when you try to get that type of capacity, you need to think really hard to get the information structured in a way that it can scale. Currently, it's supported for Postgres 16.4 and 16.6, so specific versions for now. And it uses shard groups instead of instances. It's a completely different concept, which makes this a bit special. And it's only available in a single region, so there is no global databases like in normal Aurora. And these transactions are constant. So this is what Limitless is giving. So if we compare what we had before, we had different instance types. So if we're talking about Aurora, we have fixed instance, you use the capacity, you know it, it's all fixed cost, etc. But they ended up to innovate a bit, and we ended up going with serverless. I'm not going to discuss serverless v1, v2, because that would be a nightmare, and it will take a lot of time. But the important gist on this one is that you can scale up to 156 Aurora compute units, which is good. But if we go with Limitless, it changes a bit the whole picture. So you can scale horizontal, and you have the flexibility like normal serverless. So it gives you the power to go from 16 ACUs to 6,244. So that's quite a lot, and a lot of power. So comparing the previous stuff with Limitless, it is Limitless, sort of. We'll see. So let's start a bit with this standard Aurora architecture. So we're going to compare a bit. So for those who are familiar with Aurora, you have your nice cluster, you have the writer instance, you have your reader instance, and then you have that nice storage with multiple colors. They are done for a reason, not to highlight just the presentation. It's because how Aurora writes the data on the 3 AZs, and there is always 2 copies in each AZ. So that's how they get the fault tolerance within Aurora. And then obviously there are the nice clients accessing the endpoints for the writer and the reader. So we're going to talk about the architecture of Limitless. So we have our nice Limitless database. We have our nice cluster. It's there. We're going to have this new concept, which is the database shard group. It's basically made up of transaction routers and the data access shards. So the distribute transaction routers or routers, depending from where you're coming from. It interacts with the clients and determine how to route the data to the appropriate shards. Now, one thing which is important, the asset capabilities that you normally find in databases, that is maintained. So that's a very big plus. And the last one is the shards. So where you these function as read-write nodes, and that stores and manages that particular portion of the database. And obviously, similar to what we had before, we have the distributed storage, which basically goes across 3 AZs, so you keep the data saved and reliably there. So this is the limitless architecture. Now, the shards are dependent on the storage, and obviously any queries coming in are forwarded to the routers, and from the routers it goes to the shard. So there are those nice clients accessing the limitless database. So let's go into more details about the shard groups. So as we discussed before, it is contained within the cluster, so still the same constructs that we had with normal Aurora, but it basically provides the endpoints for the apps. It handles the horizontal autoscaling for capacity, and it also contains the data shards and help with fault isolation. I didn't go into too much detail on how the failover happens or the fault isolation is there, but the way that they architectured everything, there is no single point of failures. And again, they can scale according to the load. So that is why reality is becoming limitless. And since it's serverless, that is quite easy. So there is one limitation right now, or at least a limitation. 1 DB shard per cluster is allowed. So the actual shard configuration. So it measured in ACU, so I have the minimum maximum capacity. The minimum is 16. Each ACU corresponds to 2 gigabytes of memory. And obviously associated with that, you have the normal CPU stuff and the network capabilities that requires. So in terms of when you're configuring it, it's basically very simple. You have, let's see, it works. So you have the minimum ACUs, the maximum, and most importantly, you have to put in the shard group name. So when it comes to redundancy, there are multiple options. So if you're a bit cost conscious, go for single failover, which means you're using 2 AZs. If you're paranoid, then go with 2 failover targets. If you want to sleep well, very well at night, then go with no compute redundancy. And hopefully nothing happens. My suggestion, balance between ops and cost, at least go with single. Not the best, but it's a good compromise. So let's talk about the transaction routers. So those nice routers there, they can scale. It provides a unified view to the database for clients. So you have one endpoint. It parses all the SQL queries. Even bad queries, they are handled, like my queries. And it scales, since it's serverless, as needed. One of the good things about the distributed transaction routers is maintain table references. So it knows which shards to contact. And if there are multiple shards into one response, they aggregate the value so they can present it in a structured way to the clients. And also, we talked a bit before about the consistency. There, everything is sort of handled to make sure the accurate data is passed on to the clients. So, shards. So when it comes to shards, if we focus on that part, it's backed up by the storage that we mentioned before, independently manage a shard key space with maintaining the 4 reference tables, and execute the query fragments bit by bit so that it can scale and it can cater for fault isolation. One thing to notice, it uses 64-bit hashes, and each shard has 64-bit space to it, and it can go up to 128. Now, something which to notice, although it's GA, it's available in 10 regions. So I didn't have much time to do, so I decided to add all the locations so that I show you that I know my geography. But one thing to note, it's because of US East 1. So basically, West 1 East 1E is not supported. So check for the caveats, always. You always find that nice little footprint that you don't see. So when I was playing around with Limitless, okay, there's multiple AZs. Why E is not there? I checked the documentation and found that it's not supported. So double check the documentation. Now, going more on the serious note now. It's still new, and a lot of standard features are not there. So, for example, managing the credentials for normal Aurora, one way of doing it was to use Secrets Manager. It's not supported yet, hopefully. So you cannot use the default RDS key if you want to share encrypted database clusters with RAM. So that's another boo-boo. So you need to use custom keys. Bubblefish is not supported. So for those who are not familiar with Bubblefish, you can use SQL and Postgres connections, and Babel does the translation. You cannot, doesn't support database activity streams. RDS proxy, yes, is not supported, unfortunately. It's one of my favorite features on Aurora. So yes, that's not supported. Doesn't support adding replicas for obvious reasons. You don't need it. In this case, they were right. Doesn't support global databases yet. What about if I have multi-regions? You're in trouble. And then there is also, it doesn't support the normal storage for Aurora, so you need to pay more for the I/O. And the last one, it doesn't support any type of caching. If you try to go from the other side, so RDS proxy doesn't work, can I use Elastic Cache? Nope. They need to. That's how they're doing it. And the last one, it doesn't support the RDS Data API. So Limitless went into GA last December during reInvent. So hopefully they get with these nice features on. So next time, these will be there.
They should call it limited instead of limitless.
You can. So one last thing about the query flows. I think this is important. So the router part receives the queries from the client. It's basically a summarization of all the stuff that I have been mentioning. So receive queries from the client, plans where it can be, which shards it needs to go. If there are any joins, they are done, and send partial queries with transaction context to the shard. So it receives the queries, do the stuff that's needed to do, check, get the stuff, and send it back to the router. And basically, the router does the necessary joins, filters, segregations, and then send them back to the application. So, last thing about the limitless tables. So there are different types. So there are the default ones, which is basically standard tables. Standard tables are not distributed. That means the shards are chosen by the system. If we have sharded tables, it's a bit of a different story. These can be distributed across multiple shards, and data can be split accordingly. And these usually are sorted out through the shard keys. And the last one is the reference table. So these are replicated to all shards. So watch out. Why? Because if you're not careful, you're going to have quite a lot of increase in the actual size. So join queries between reference and sharded tables can be executed, which eliminates processing going back to the router and back to the shards. So watch out on the actual syntax that you're going to to use for these reference tables. From the documentation, which is, by the way, very limited yet, they mention zip codes. And if you want more information, there is that nice QR if someone wants to take. Okay, yes, there is one. Take your time, I hide. So you can refer to that. And one taking more, yes, that is the last one. Okay, no more? No more, okay. So, changing a bit the topic. So, I'm going to put a disclaimer here. It's still in preview, as you're gonna see. It's free for once, but there is no documentation at all. Very, very limited. So, similar to the new features that were mentioned for the DynamoDB, same regions, US East 1 and 2 for nodes, and US West 2 for witness. We're going to get into detail what these two means. And disclaimer, limited feature set at the moment since not GA. It is so limitless in terms of features, there is no backup options, just FYI. So yes, they're still work in progress.
Who needs backups?
Yeah, I mean, they have good SLAs. So what is DSQL? So it's, again, serverless. Serverless seems to be the magic word with Aurora nowadays. It's highly scalable, virtually unlimited scaling, zero infrastructure management, no need to patch, no need to upgrade. It's all handled for yourself, by themselves, not yourself. So that's quite good, I would say, as an SLA. So if you go with multi-region, it's a good thing. So potentially, if you want to risk it a bit, you can go without backups. But still, unfortunately, backups are needed, especially if you consider ransomware scenarios. And it's also synchronous, so no more racing stuff. As it is supported, so that's quite nice. And this is Aurora DSQL. Now, DSQL is Postgres compatible, yes, but obviously there are some nice limitations or feature set. So the first one, it's based on version 16. It uses the full Postgres parser, planner, all the stuff that you normally find in Postgres. So basically, using normal Postgres and this, it will return the same query outputs. Supports for the common SQL expressions, selects, create, the normal stuff, and there will be limitations that are coming in the next slides. And it also uses the optimistic concurrency control, so basically no deadlocks and no pessimistic lockings. So basically, all the conflicts are detected at transaction commit, so that is quite nice. So that is how AWS are achieving to have multiple rights in multiple regions. So that's quite a good achievement. So the SQL components. So we're going to start with front-end transaction session router. Why I'm putting all those names? According to when I was preparing the presentation, the official documentation, it's transaction session router. Last week I was in Prague, I attended a workshop, and guess what? They put it as front-end. So I put them in both. So basically it acts like similar to what we discussed with Limitless. It's the entry point, do the connection pooling, load balancing. It interprets all the SQL stuff. So very similar to the previous stuff that we have seen in Limitless. When it comes to query processor, this is a new concept. It uses Firecracker, similar to Lambda. And basically, it scales. And that is why the power of DSQL is coming from. Now, one of the things which we're going to see, if we're going to have read operations, they go directly to storage. When it comes to write operations, they need to be checked if there are conflicting commits. So this story is a bit different. We're going to have a slide purely on this part. But it's important. Reads straight to storage, read them, no locks, no anything, because the query processors know which part of the information they need to retrieve. So no table locking, no record locking, all that stuff, that's from the past. So the next one is the adjudicator. I mean, the name is self-explanatory, but basically it looks for conflicts between transactions and try to determine the best way forward, hopefully with a smiley, and it will work. There's the journal. This is a very important layer. Usually with normal databases, where is the data durability? It's on the storage. With DSQL, is the journal. So every transaction that is happening, there's a record in the journal. Obviously, or for obvious reasons, that journal needs to be highly available. So once we have that multi-region option, it will extend the journal through the first region, the witness, and the second region. And there is always 2 out of 3 available in case of failure. We're not going to cover failover, but the way it's designed, that if a region fails, nothing happens, everything will work. And the data consistency is maintained. And the last one, guess what? Is the storage. Same stuff that we discussed before, and it applies to DSQL. 3 AZs, everything redundant, the storage is there. So let's talk a bit without the single region architecture. So we have our nice application, AKS, CCS, CC2s, whatever you have. You have the endpoint, you have the 3 AZs for the endpoints, they have the compute stuff, there is the transaction, and there is the storage. This is the official diagram that you get from the AWS documentation. So copy-paste. It's there, it works. I only changed the icons to make it more, rather than application, I put something more appropriate. And obviously it's multi-AZ. So in this case, the SLA is 99.99. So it works. In case of failures, it can recover without any problems. The multi-region stuff, that gets a bit complicated. So we have this nice synchronous replication. So basically you can write local, and basically the data then is synchronized through the journal. The journal, although it's not in the diagram, it's available in all the 3 regions. It's important for those people who work with these kind of scenarios or applications, you know that you need at least a good quorum. And the witnesses there is to have the quorum, which is 2 out of 3. So this will avoid the split brain scenario. And if there are 2 failures, then it stops. Then the service is not available. As I asked specifically this question. So if I lose the connectivity to both regions, witness and the second region, what's going to happen? That will stop because you lost the availability of the quorum. So we're going to talk about flows now. So we're going to talk about the read operations. So we start with the endpoint. We have the query processor, and as I mentioned before, it goes directly to the storage. It will bypass the adjudicator and the journal. When it comes to write, the situation is a bit different. We still have the endpoint, query processor, and we have the adjudicator, and then the journal. And lastly, the storage. So In that case, it needs to go for the whole flow. Why this is needed? To ensure that if there are any conflicts, then these are solved before committed. It's not mentioned in the slides, but it used the new time sync service that AWS built, which is highly accurate when it comes to determine which commits need to be executed. It's very time-based specific. So accurate timing is crucial for this, even for Limitless. So with this new time sync thing that they are using, they are complementing the AWS compute infrastructure, where now, similar to the Nitro components, there is also a time circuitry specifically on each compute module that they use, or compute equipment that they use. So this is very, very, very important when it comes to the time. And all this, I didn't put in the diagram the queries processor scaled in multiple times for all the services and the full mesh, because otherwise it will be a nasty diagram. But bottom line, there are no single point of failures. And most importantly, if I need to scale for whatever reason the adjudicator, it's totally independent with the query processor and the journal. So that can scale accordingly to what is required depending on the load. So, considerations. Unfortunately, still in public preview. There are stuff which are not supported, like views, triggers, normal stuff that normally use within DBs. There are also some operations. One of the most requested features are the foreign keys. Yes, they're not supported yet. And there are also some nice extensions which are not there. And one of them is the PG vector. So you can't put vector stuff in it. So you can't use it as a backend for Bedrock, at least for now. And there is also like some other stuff which is not supported. Now, the list is much longer, so I'm gonna move back to if someone wants to take this stuff for the nice featureless limitations. Is there? Okay, any more photos? Yes, there's last one. Yeah, okay. Come on, I need to move forward. Yes, why it's not working? Click. Let's see. Okay. So takeaways on this one. Choose the right Aurora feature for you. We didn't cover the normal Aurora stuff. For the bulk of use cases, it's still good. So if you want to do blue-green deployment, if you want to use RDS proxy, if you want to use Elastic Cache in conjunction with it, all that stuff, that is with normal Aurora. If you have global requirements, then you can't use Limitless because only right now with one region. You can't go on production with DSQL for obvious reasons. It's still in preview. And again, there are features which are not okay. So, thank you. Hope you enjoyed it. And please, good feedback and 5 stars, please. It's important.